The double-slit experiment sits at the heart of quantum mechanics. This experiment reveals the surprising behavior of the universe at the smallest scales. Imagine a barrier with two narrow slits. Behind the barrier is a screen that can detect particles. Now, imagine shooting tiny particles like electrons at the barrier. If only one slit is open, the electrons behave as expected. They pass through the open slit and hit the screen directly behind it. This creates a single band on the screen. However, something remarkable happens when both slits are open. Instead of two bands, the electrons create an interference pattern. This pattern resembles the way waves interact with each other. The electrons act as if they are waves, spreading out and interfering with themselves as they pass through both slits. This wave-like behavior is one of the most profound mysteries of the quantum world. The double-slit experiment gets even stranger when we introduce the act of observation. If we try to observe which slit each electron passes through, the interference pattern disappears. Instead, we see two distinct bands on the screen, as if the electrons are now behaving like particles again. The simple act of observing seems to change the outcome of the experiment. This is known as the observer effect, and it has puzzled physicists for decades. It suggests that the act of measurement, of gaining information about a quantum system, fundamentally alters the system's behavior. How can this be? One interpretation is that quantum particles exist in a superposition of states. They are in all possible states at once until we observe them. When we observe an electron, its wave function collapses. It chooses one state, ending the interference pattern. The bizarre nature of the double-slit experiment, particularly the observer effect, has fueled some intriguing speculations. One such speculation is the simulation hypothesis. This idea proposes that our reality might be a highly advanced computer simulation. Proponents of the simulation hypothesis point to the observer effect as possible evidence. They argue that the act of observation in the quantum realm could be analogous to a computer rendering only the parts of a simulation that are being observed. Just as a video game optimizes its processing power by only rendering what's on screen, perhaps our reality does something similar. The wave function collapse in this view could be seen as the simulation updating itself based on what is being observed. While this idea is highly speculative, it highlights the profound questions that the double-slit experiment raises about the nature of reality. While the double-slit experiment provides fodder for the simulation hypothesis, it's crucial to emphasize that it does not prove we live in a simulation. The experiment's primary contribution is to our understanding of quantum mechanics, not as proof of a simulated universe. The scientific community largely interprets the double-slit experiment and the observer effect within the framework of quantum mechanics. While these phenomena are strange and counterintuitive, they have been repeatedly confirmed through experimentation. They are consistent with our best understanding of how the universe behaves at its most fundamental level. The simulation hypothesis, while a fascinating thought experiment, remains a philosophical idea rather than a scientifically testable theory. The double-slit experiment, with its baffling wave-particle duality and the observer effect, stands as a testament to the mysteries that still abound in the quantum realm. It underscores the limitations of our classical intuitions when trying to grasp the universe's fundamental workings. Remember to like and subscribe.